Java interview questions. Today we'll be going through more questions of Java and I have like 17 minutes of a slot. Let's just do it. So the first question is when you can use super keyword. Super keyword in Java can be used to call the parent class. So let's say there's a parent class and the child class. So super keyword can be used whenever we want to call the parent class constructor, parent class method, parents class instance variable. That time we can use super keyword, right? And with super keyword, it has to be the first line whenever we are using super keyword in any of the code block, right? So let's just go through what I have written. Super keyword can be used in case we want to call the parent class methods from the overridden method, default of parameterized constructor, to call the instance variable, first line of code. This is important because I have seen one of the output based problem where they are asking whether what this will be the output of the particular code where they have used super and this keyword. And first of all, both super and this has to be the first line whenever we are using, right? So this is important. In that case, we'll have a compilation error. Can the static methods be overloaded? Definitely. Yes, static methods can be overloaded. Static methods can be overloaded because static methods belong to a particular class and static methods. I can take an example of public static void main. That method we can override. We can have same method main with different set of arguments, different order of arguments, right? But with main method can also be overloaded, but JVM will only call the particular main method that follows a particular syntax. Same one only JVM will call. You can have a number of overloaded methods. Difference between static methods and variables and static classes in Java. Static methods. So whenever, let's say we have a class, we have an instance variable, we have member functions. Whenever we get an object of a particular class, we'll have a unique copy of this instance variable as well as the member functions, right? But static methods, static variables, that is not the case. It will have one single entity, it will have one value for all the different objects. So let's say we wanted to count something. Let's say example of, let's say we want to count, merchant ID and we want it to be like in a sequential manner. So in that case, we can have a variable called static merchant ID and we can use this merchant ID in every object that we are creating. That time we can use the static variables to increment it, right? We can use that particular method with all the different classes. Okay. Okay, what is the main objective of garbage collection? Simple. Garbage collection is very simple. So let's say the main objective of garbage collection is to free the heap memory. That is the main objective. How it does internally, we can't go into details. There is a whole lot of things. But what it does is, let's say we have an object and that object is not being referenced, not being used. In that case, that garbage collection kicks in and it will free that particular memory, right? So by removing the unnecessary and unreachable objects during the Java program execution, it basically free up the memory. But it will, this is one of the good point, but it will not make sure, but it will not ensure that there will be enough memory for the program execution, right? Because it can happen like a program, let's say we are running a Spring project. In that time, garbage collection is running, it is clearing the memory, but it will not make sure that the program will keep on running. It will have enough memory to run the program. You know why? Because there might be other parts of a program that is also creating objects and we can have out of memory error, right? Out of memory error, heap will be full. So it doesn't make sure that program will keep on running. It will have enough memory to run the program, right? It will just work. It is like you are cleaning the room and on the other side, someone is stepping on the floor and making it dirty, right? You can make sure that the room is clean on that part where you clean, but you cannot allow other metrics so that the more memory will not be consumed. Okay, what is class loader? Class loader is part of JRE, Java Runtime Environment. So we have JDK and inside that we have something called as JRE and inside that we have JVM, right? So JVM is the actual engine which runs our program. So from JRE, what class loader basically does is whenever we want to create and instantiate a particular object, that time we need a particular class. And that time itself, this class loader, we go search for the particular file and it's going to load it to the JVM, right? Let's see, whenever JVM needs to load a class, first it check the class is already, okay. The process is like this. First, it will check whether the class is already loaded or not. If it's already loaded, there is no need to go and fetch the particular class. Complete class path will be used to load the class, and JVM does not need to know about the files in the file system because of the class loader. So here, what we are basically doing is we are dividing the responsibilities. Why to put everything on the JVM, right? So we are putting this responsibility to know where the class is on the class loader rather than JVM. Okay, and this is also a really nice point that all the classes are not loaded at once in the JVM. It will be loaded when it is required. So there are three types of class loaders: bootstrap loader, extension loader, system loader. I don't know about these in detail. I don't feel like no one's gonna ask you them in detail. Yeah, if it's required, I can go through that, but I don't feel like. Okay, so let's understand what is shallow copy and deep copy. This is very simple, right? Shallow copy is, let's say we have an object merchant. I'm taking example of merchant only because that's what I use in my projects. So we have a class merchant, it has merchant ID, merchant name, right? And in that case, shallow copy, how it works is we create an object merchant M1 is equals to new merchant, and we have created an object. Let's say now shallow copy, how it works is I'm getting another reference variable merchant M2, right? So what I can do is I can point this merchant M2 to the same object which is being created in the last. What I will do, merchant M2 is equals to M1. In that case, two reference variable will be there and they will point into the same memory location. That is what shallow copy is. But in deep copy, what will happen is, a new object will be created, right? So in deep copy, we will be creating a new object, and that object will have its own heap memory, heap location, right? It will not use the same, you can say memory location, right? You can also do this using clone method. M1.clone, what it will do, it will create a new memory location for us for the instance variable, and we can use that. So let's understand what is Java intermediate core Java question, that is a little bit on the higher side, right? Not on the easier side. So let's understand okay. What is the main reason behind making strings immutable in Java? So yeah. Strings are immutable in Java. So if folks doesn't know this, strings are immutable in Java, what does it mean? It means that if we try to modify a particular string object, a new object will be created, right? So what does it mean? So let's say we have a string pool where all the objects will be stored, and the string hello is stored here. And now I concatenated this with world. I do hello plus world. So in that case, what will happen? A new object hello world will be created, and that will be pointed to by the reference variable, right? So that is what immutability means. Okay, why it is done? It is done because string will be mostly used by the Java developers. Okay, so what James Gosling thought is he doesn't want us to create objects again and again. So let's say there's a one object string 1 is equals to hello and string 2 is equals to hello. In that case, both the reference variable will point to the same memory location. In that case, we are saving a lot of memory, right? And hence strings, that is why the string is faster, right? Second is immutability. Why it is being introduced? Because of multi-threading concept. Because if something is immutable, we can share them with multiple threads, and there's no need of external synchronization required. And hence it is very cool, right? Third is collection, because in collection like hash map and hash tables, we use string as a key and we want it to be like immutable, right? We don't want it to like modify it again and again. Someone can go and modify it. We don't want that. Okay. What is singleton class in Java? Singleton class in Java means, okay, so the next question is singleton class in Java. Singleton means at a time only single object of the particular class is present. Okay, how we can make sure that is we can make the constructor as private, right? We'll have a reference variable and we will have one method that's going to check whether the object is null or not. And if the object is null, then it's going to create a new object, otherwise it will return the same reference very same object. Let's take an example of water jug. Let's say in an office there's a one water jug. So every time someone wants to drink a water, they will take the water jug, see they will use the same water jug and pour the water into their cups and they will use it. So let's see how we can do this. What we can do is we'll have a variable called water quantity. So what we will do whenever we are getting the water, we'll reduce this. So we have a method called that, and we have a method, static method. Why have we have made this static? Because of the reference variable is made static, and that is why we have to make it static. This method will check get instance whether the object is null or not. If object is null, it's going to like create a new object and return it. If object is not null, it will return the same object, right? You can also see whether if you do like water jug dot get instance, water jug get instance, every time it is returning the same object. How we can verify this? We can use equal operator, or we can use hash code method to verify that, because hash code of all the reference variable will be same. Okay, now we can jump to the next part. What is the hash code method? Hash code method, equals method, all these methods are basically toString method are basically part of an object class that is superclass of all the classes. This method is used to create unique integer for each object, right? And when we call the equals method on two objects and it's true, it makes sure the hash code is also true, but reverse is not true. Sometimes what can happen is two objects can have same hash code, but it doesn't mean that their values are also equal, right? Whenever we are implementing a hash code method, we also need to implement the equals method, how we want to equate those particular object so that both the things are verified. We are checking whether equality is working and we are checking the hash code is working or not. Explain example of working on equals method. I know equals method, leave it, string build and string buffer. Okay, so let's compare string build and string buffer. String uses string pool, but a string buffer and string builder, they uses heap, right? And string is immutable, but string buffer and string builder, those are mutable. Efficiency wise, I would say that string builder is the fastest, and then string buffer, and then string. Thread divided string is thread safe, right? String buffer is also thread safe, but string builder is not thread safe. Right. Okay. Okay. Now understand difference between abstract and interface class in Java. Okay. So what is an abstract class? If there's a class and that class have one abstract method. Abstract method is what? It has abstract keyword and it does that method doesn't have a definition. That is the abstract method. So if there's a class which is having one abstract method, then we're going to call that particular class as abstract class. In interface, an interface will have abstract methods, plus it can have default and static method, but mostly it will have abstract methods, right? Class can extend only one abstract class, but you can implement as many interfaces we want, right? There's a very simple example. We are having an abstract class portfolio where we are doing get portfolio ID, and there's a method called abstract void print resell info, and we can override this class and we can give the definition of this particular method. But so in abstract, we had a choice whether we want to give the definition of this particular method or not. If you're not giving, we can make this also abstract, but in interface, we don't have a choice. We have to override the particular method. Okay. Comparator in Java. Comparator is a really cool thing in Java. Let's understand this. Let's say I wanted to sort a particular array list which is having an object. I can use collection.sort and sort it. But let's say I want to sort it on a particular criteria. I want to use merchant ID. I want to use merchant name. In that case, we have to give our own implementation of which compare method will be used by the compared sort method, right? So in that case, we can make use of comparator, right? Comparator objects can be used to sort the user-defined classes. It can be used to compare the objects of the same class. There's a very simple example, right? Let's say we have a student class and we wanted to sort using student ID or student name. In that case, we can create two different comparator. One is like this one, sort by roll number. Here we have implemented the comparator interface, and what we will do, we'll override the compare method. and we can give our own definition. This compare method should return 1, -1, 0, positive, negative, or 0 to sort the variable. Similar way we can also do using if you want to sort using name. So while how we will use it whenever we are calling collections.sort, at that time we'll pass the particular array or array list. At that time we'll pass the object of any of this class which we want to use to sort. Makes sense? Few other things that we can use is let's say we have list of numbers and we want to convert it to an array list. We can use this method array list integer list is equal to new array list, and then we can give arrays.asList particular array we can pass. Here we can also pass the array. We can pass individual values, whatever we want to pass. Similarly, we can do for a string. We have string array string.asList. We do it this way. We can also get comparator like this. We don't have to like implement an interface and we have to override the compare method. Since comparator is a function interface, it has only one method. We can do it this way also using lambda expression. We can create a comparator, which class we want to use, right? String we want to use, sort what method name we want to use. Right, this is the class name we have used in the past, and then we can pass the particular function. We are sorting based on the length. Okay, sort by length to. Okay, difference between hashed and preset. Simple hashed and preset both have big hashed as big of 1 to read a particular element. Okay, hashed and preset both will have a unique values. It will not have duplicate values. Difference is hashed will not maintain the order of the elements, whereas preset will maintain the order of the elements. To read element from hashed is big of 1, right? And hashed uses hash code and equals method to compare the object, where preset uses compare method for the same. Performance is faster in hashed big of 1. Since it does not maintain the order of the element, whereas preset maintains the order of the element. And there's something called a sorted preset also, which can sort the elements as you're storing it. So it takes log n for the same thing. Why it is recommended to use getter array over string in Java for confidential information? Because in Java, we are using something called a string pool for all the string objects. And if anyone does the heap dump during that time, they can have a string is immutable and stored in physical heap. The string pool and there's any modification, a new object will be created. The old one remains in the memory, right? Old one remains in the memory, and that time if someone does the heap dump, they will have all the objects and they can use it against us. That is why it is recommended to use array, use that, and once it is used, discard it, right? So that it can be read by the heap. And this is not a string pool, it is to be stored in the normal heap. What are the different ways to use that? Extend set class, implement enable interface. Implement enable interface is the idle way. Override the what run method, and then so let's say we can implement a runnable interface, override the run method, and then we have to create a thread object, pass the particular class name, object name, and then we can call the start method. We can call the start method, and JVM will internally call the run method. Fine. By the start method, we are getting a new call stack. Okay, so this is a really nice point. Whenever we are calling a start method, we are basically getting a new call stack thread for that particular thread execution. And once the call stack is created, JVM will internally call the run method. We are calling the run method, right? Okay, we have to go through this one for now. Okay, so next session will be on this. Bye bye.